Hi, everyone. Thanks so much for being here. I'm Masana Bazada. I'm the Chief People Officer here at Melbourne Space Program. But I would like to first begin by acknowledging the traditional owners of the land on which we're meeting today, the Wurundjeri people of the Kulin Nation. I pay my respects to their elders past, present, and emerging, and extend that respect to all Aboriginal and Torres Strait Islander people here today. For those of you who are new to the community, Melbourne Space Program is a student-led initiative that's dedicated to exploring the frontiers of space through innovative technology and a spirit of collaboration. And our mission is to develop the next generation of tech leaders, inspire innovation, and create pathways for students to engage with real-world challenges in space exploration. And over the past year, our team's been working tirelessly on several projects, including Animatronics, Humanoid, and ACRUX2, which we will hear from later this evening. Tonight, we're here to celebrate the achievements, to recognize the hard work and dedication of our teams, and to share our vision for the future. This annual showcase is not just an event, but a culmination of a year of passion, innovation, and relentless pursuit of excellence. I myself got involved with MSP last year at the start when I joined university. I moved down here from Brisbane. And when I first heard about Melbourne Space Program, I honestly didn't realize that I could be a part of it. But since joining, I've had an amazing journey. I've met some amazing people. Amazing leaders who I call my mentor today. So it's been an amazing journey. And also some of the reflections that I would like to reflect as part of my journey in Melbourne Space Program is I think there's so much power. Melbourne Space Program has shown me that there is so much power in curiosity and passion. It was really curiosity that brought me to Melbourne Space Program, a desire to just learn more, to contribute to this organization, but it was passion that kept me here. And curiosity really opens doors to new opportunities, and passion drives you to walk through it. Space exploration, much like life, is full of unknowns and lots of unexpected hurdles. So there has been times in our projects where things haven't gone as planned, as happens in our everyday life, when we're faced with technical difficulties and when progress seems slow. But with each setback, it's been a learning opportunity, teaching us to adapt and to innovate. And lastly, I want to inspire each of you to dream big and push the boundaries of what's possible. The universe is vast and full of mysteries waiting to be explored, and so is the potential within each of us. Let us not be afraid to take risks and to step out of our comfort zones and imagine a future that goes beyond the ordinary. The work we do here at Melbourne Space Program is just the beginning. It's stepping stone to greater things, and I'm really excited to see where this journey takes us all. So thank you so much for being here tonight. I'm really excited. Thanks so much for your support of Melbourne Space Program. I'm really looking forward to meeting you and opportunity to network with you. I would like to now ask our CEO, Sam, to come and present his address.
Cool. Awesome. Thank you, Masa. And as she said, I am Sam, and I am the CEO of Melbourne Space Program. And so I have been doing robotics for quite a few years, well, at least as a student. I started in 2016 with my high school robotics club, and that was all about designing a robot to compete in rescue competitions, going to disaster environments where humans can't go into and detect life, survey the area. And one thing I really loved about that was that there was a great sense of community and collaboration. The entire competition was open source, so everything you designed, everything you coded had to be uploaded to the internet so that every other team could find it, use it, and that sense of community to work forward and for everyone to progress together. And it's this competition which led me to decide to study mechatronics at the University of Melbourne, which I am currently in my master's of. And it was through this that I also got involved in a number of other clubs, including the University Rover team, which I ran several parts of. And through this, a year and a half ago, I was invited to join MSP to restart the Humanoid team by the CEO of a few years ago, Patrick Grave. One thing I loved about these student teams is it really gives every student that's a part of them a chance to work with other students, build that practical experience, and just collaborate with others so that everyone can learn. And even for the project teams that are competing against each other, so many of them still collaborate and work together to help each other, even so they are still competing. And this is something I love about MSP, and I want to bring more into MSP, is that ability to collaborate and work with other people. And so that's been one of my aims, to try and change things around so that everyone has the opportunity to try new things, see how they go. University is a great time in life for trying new things, finding out where you want to go in life, and just kind of giving it a go and see where you end up. So, and you'll hear from these teams shortly, our Acrux Humanoid and Animatronics team that gives students this opportunity. But also, this event would not be possible without the people working behind the scenes. They may not be working on something technical, but our marketing, business, and management teams, which work behind the scenes tirelessly to help create, run events like this, and to give our projects the support they need. And I'd also like to thank our sponsors and Innovation Week, our sponsors here, and Innovation Week for giving us the support that we need to run these events, run these projects. And yeah, without further ado, I would like to invite our keynote speaker for the night, Preetham, to come and talk.
All right. Good evening, everyone. My name is Preetham. I'm the CEO and founder of Akulatech and a proud alumni of Melbourne Space Program. Now, let me figure out how to operate this. Yes, and that's my company. So I'm here to talk about my journey, how I got associated with Melbourne Space Program, and then how that ended up, or how that is running as Akulatech right now. I think the motivation for me to come here and speak about my journey is to basically show an example of where you can get to being part of such student teams, and also just showing, where we are right now, what we are doing, and what you can look forward to once you come out of universities and once you look forward to getting into the industry. That's me in 2019, when I first started at RMIT, my aerospace engineering degree. Disclaimer, you're going to see a lot of fluctuations in my fitness, so please ignore that. So that's when I started my aerospace engineering degree, international student, flew down from India, have no clue how Australia works. A lot of mistakes in the beginning, and eventually I ended up joining the rocket team in RMIT, and this was in my first semester. That was one of my interesting experiences as a part of RMIT. That's the first rocket that I built, which didn't fly, obviously. But that actually introduced me to what hands-on experience is, and what it feels like building something that you can actually take out to a field and try something out with it. Even though it blew up, it just felt so good. At least, I could blast something. That's an achievement. Then this is I hope the video plays. This is actually the rocket that flew, and that was successful. So the video, I don't know if it plays, but. Then I was involved in the team that built that big rocket that I'm holding there. So this whole journey is actually where my first step towards doing something in space industry started. Before this, I was more thinking along the lines of going into PhD, publishing papers, and working with researchers. But after this, I realized I'm not cut out for PhD. I want to be doing something more hands-on, blasting stuff, blowing stuff, and then building stuff. So that's point of realization for me. And I think the reason I put these slides in here is obviously you guys have gone through that and you're part of a team, you're volunteering. That means you're actually taking time out of your own interest. But it's a great experience for me being part of such a team at university. And that's my first step towards looking out for more such opportunities where I can do something more hands-on, where I can apply my knowledge that I'm getting in my classes, although my grades weren't great. And that's when I, also explored joining Melbourne Space Program. Unfortunately, I don't have pictures from my time at MSP, but this after I was a part of MSP for about a year, and then I went off to do my Airbus Defence and Space internship, for which also I don't have pictures, for obvious reasons. I was working on a telescope project, which is a bit of a confidential project, but I was an intern in mission design team. So that's, I'd say, my time at MSP actually helped me understand how how space missions work, like space missions are developed. Because when I joined, we just finished ACROX 1 and we were planning ACROX 2, although the plan was a lot different back then. We were supposed to launch a electrodynamic tether built by Sabre Astronautics, and they don't do tethers anymore, but back then they had a tether. That's when I learned about how to put together not just a technical team, but also other parts, other bits and pieces of space missions, like management, like human resource, marketing, and business development that Sam just mentioned. Building on that experience, I think MSP played a really important role in accelerating my journey towards having my own company. I think if it was not for MSP, probably I would still be in the early process of building a company, or even not have a company, but just an idea of having a company. But I guess my journey with MSP helped me sort of accelerate towards that direction. And then obviously Airbus Defence and Space got me good connections, which then sort of laid the foundation for the whole startup idea. But then space companies are expensive. I've got to burn through millions of dollars even before I can prove something that my company can do. And that's where comes the dropout chaiwala. So I realized early in the journey that I need a financial foundation for myself before I can go out into the market and start running a space company. I tried going around with the presentation explaining people that I want to start a space company, and Australia being Australia, I've got very interesting responses, one of which is, you're an international student, you're going to be kicked out of the country. So, I realized that it's fact, it's true. It's so, although it's been told in a harsh way, but it's the reality of the industry. I don't have longevity in the country, or didn't have back then. So no one's going to put $1 million into my company just looking at a 10-slide presentation. So that's when I realized I need to have some money by myself to burn, which then will give me that initial runway where I can build something that's more substantial, that's more demonstrable, and then from there I can raise funds, or at least hope to raise funds. That's the reason behind starting Dropout Chaiwala with a couple of my friends. And we did this as to be very honest, this was my do or die. If this works, I'm in Australia. If it doesn't work, back in India, helping my dad with his business. And we started, so Dropout Chaiwala is a cafeteria business. It's still running. I'm sure some of you guys would have known what it is or tasted it at some point. When I started off with like a savings, whatever we had. International students don't get to save much money, but somehow we did. So we just put all of that into a single business, and that was a moment of truth. From there, this is our 100th cup that we sold in the cafe. So it was a success. Turns out Melbourne loves chai as much as coffee. So it was a success. We made quite a bit of money, of course, and we also made quite a bit of experience in running a business. There's one thing running technical business, but there's another thing running a business in itself. So that's where I've learned a lot of things. I call this journey in Dropout for 2 years as my MBA, where I didn't pay fees, I made money. So I've learned a lot of things. I've learned money management, I've learned taxations, I've learned GST, what's GST, when we should pay GST. Interesting aspect is we didn't pay GST for a whole year, thinking that it's a end of the year payment, and then we realized the end of financial year is June, not December. So we had to pay a bit of a fine. It's an expensive lesson, but we did learn it. And in addition to that, I've learned a lot about people management, how I can bring people of different... one thing I did realize is talented people have different personalities. Along with talent comes something with it that needs to be managed within a team. And I think that's where I've learned how to bring clever minds to a single room and make them not fight, make them build something progressively. So that's part of, that's my experience being part of Dropout. And then we expanded to second store, which was quite an achievement back then for us. Even now it's an achievement. So we quickly expanded to a second store. I think it's in about a year from the first store, we opened up our second, and that was also a bit of a flagship store with merchandise and all of that in it. And that's where I made my money as well, the second store. And that's when Akula Tech happened. The reason I named Akula Tech after my last name, I've never told anywhere in public this, is I wanted the name to reflect my passion towards this company. And like I keep telling my staff or my team members, this company is not for me to make money. This company is for me to leave legacy behind. And that's why it's named after my last name. And also it was my father's dream to have a business after his last name, which he could never do. So kind of an emotional connect. But the intention behind this company is I've started this to become the next Lockheed Martin, which can exist for the next 100 years, next 200 years, if possible. My intention with this company is not to build something for 5 years and sell it for a hefty check and then buy a yacht and relax on the docklands or something. My intention is to build a legacy, build a company that can compete on the global stage right from here in Australia. And I think Australia being a strategic player in the geopolitical situation right now, I think that's a huge opportunity. And that's what I observed, that there is room for becoming a legacy and a large company right from here in Australia. I hope the government believes in the same thing as well. But that's my intention behind naming it after my last name, which basically the same story of Lockheed Martin as well. And from there, this was me in Avalon. That's where my first step towards an active business. Till then, it was all idea. There was nothing on paper or nothing even developed. Avalon was, I basically just borrowed $20,000 from a friend, telling that he will never get it back. I was honest. I told him he'll never get it back, to buy a stall in Avalon because we were not given the startup discount for some reason. And then we put up a stall. And my reason for attending Avalon was I know there are going to be a lot of students looking for jobs. And I wanted to build a team. So I thought that would be a good spot for us to sort of, meet people, motivate them, give them a bit of a startup knowledge, and then try to get them to buy into my vision and join my team, because I didn't have a team. So that's when I met Nish sitting at the back, our chief AI officer, if you can wave for everyone. Yep. So he was that person looking hungrily for jobs, and he was actually quite sincere in that conference. He had a whole book noting down names of the people and the conversations that he had, and almost had like a hit list where these are the people that he wanted to go and talk to. And that is what caught my attention, and I sort of started talking to him, and I asked him to join the company. I don't know why he did, but he did. I'm interested to find out one day. Nice. I hope it is actually true, but yeah. So he joined the company, and then from there, in 2 years, we are now a company with a flight-ready satellite, about to fly in about 3 months from now. It was supposed to fly in September, but then our launch vehicle kept delaying it. But I think we are one of those very few companies who has a flight-ready satellite with just seed funding and in under 2 years. And that's our satellite up there. It's a Earth observation satellite equipped with AI on board, obviously, like most satellites are now. But our satellite can actually do a lot more than just doing image inferencing in space. Our satellite can actually learn from the data that's coming from various sensors, evolve and adopt to the evolving requirements of the mission. And our satellites are also built, the software is built such that you can transfer any ground-based models up into the satellite, and the satellite will be able to execute those models in space. So that sort of features is what we built. I know I've not done a good justice of the innovation that Nishk has brought into the satellite, but I hope he'll get a chance later to maybe talk about it. But yeah, that's our first satellite equipped with a hyperspectral imager, and it's intended to be looking out for bushfires. I think we're actually launching just in time, because December to Feb is probably the season where the fires are going to be. So we probably will catch some fires. But the idea is we will be able to detect the fires and report it down to the end point in under 10 minutes. So that is sort of the concept of this satellite, and that's where we are demonstrating our real-time inferencing capability, and also the onboard machine learning, and also the detection and accuracy of the inferencing, I guess, on board. We also qualified for X Prize using this satellite concept, and this our like the capability we have in the satellite. We are one of the 2 Australian companies to qualify, and one of the 20 global companies to qualify into the next round. Hopefully, we'll make it to the subsequent rounds as well. We're actually just coming back from Sydney from a X Prize conference, not X Prize, emergency fire management conference. And this is just a pic from our office. That's the engineering model of the GPU that sits on our satellite. It's obviously made by NVIDIA. We are not yet making our chips, but the software on top of it is completely in-house built. And that's niche disk with about 6 screens there, a classic software engineer. But yeah, the idea is we are using this as a demonstration for our software, and hence we have a pre-flight heritage hardware on top of it. But from here, we're going towards making our own hardware as well, which is going to be far, far advanced than what we have right now. So we're first demonstrating the software of it, getting a flight heritage. The second mission is the hardware of it, getting the flight heritage. And the third mission is the manufacturing method of the satellite and getting the flight heritage for it. So that's a step-by-step incremental flight qualification is what we are trying to do with our missions. And while doing that, we're also hosting customer payloads, which sort of brings us a bit of a revenue channel, pays for itself sometimes for a few missions. So in all, we figured out a business model where we actually get our missions almost for free, where the space on the satellites has been commercialized by giving it out to payloads. And that's the flight model of our satellite. So that's sitting in India right now. So this is just before the start configuration, just before going into the flight qualification campaign. That's sitting in India. Waiting for launch with the PSLV rocket, which has been delayed for a couple of months now, but hopefully we'll launch it by December this year, or Jan next year. So yeah, that's the company, and that's our 2-year celebration. So we were 2 years old by June. June. We were 2 years old by June. 2 years, and we already have a satellite. We have a business pipeline of $40 million. We have a couple of government grants coming through, and we also have on top of everything, we have a very, very, very highly talented team. All the people in the company, I've sort of poached them from different places. They're all the people that I worked with at some point in university as a part of an assignment or a project or a brief experience. And we also are fortunate to be supported by the people like Alan Finkel, who's visited us, given us some good advice, and also is always open to helping us here and there. And then we also onboarded Greg Hunt, who's the ex-health minister and also the sort of the brains behind Australian Space Agency. And he's joined us as an advisor, helping us with business development, international connections, etc., etc. He brings a whole wealth of connections and knowledge. And that's the place where our satellite is built in India. Bit of a clean room, and I don't want to go into details there because I don't myself know what they are. But that's actually a manufacturing center we're looking to build here in Melbourne. We're working very hard with the state government to get them interested and to get them support us, because it's in their best interest as much as ours. So that's the layout of the center that we're going to have here, which means I'm looking forward to having some of you guys join us and work there in those centers. And this is just to talk about what is the future for space industry in Australia. Although there's mixed opinions, I'm still hopeful. There's quite a few opportunities for all of you guys to actually become space engineers, doing different things in space, not just technical. And some of the companies, some of the projects that are running right now across different domains, and the idea is there is hope. Look forward to it, and definitely there are good companies coming up along with us. And that's a QR code. If you guys want to join us, please scan and send your resumes, and we're happy to sort of look at what we can do. And also follow Australian Space Agency. I'm sure they can do quite a lot than what they're doing now, but I really appreciate what they're already doing. They've got quite a few opportunities, especially I wanted to throw some light on non-technical roles, because that's the most important part, and that's the part right now we are struggling to build in our company, because it's an awareness that we have to create first, that yes, people outside the engineering domain also have a future in space. And that's me. I hope I was not over time. Thank you.
Cool. Awesome. Hi, everyone. Thank you for coming to our showcase. We're so honoured to have you all here tonight. I'm Victoria, and I'm the project manager of the ACROX team. And this is Keshav, who I'm co-leading with, and he's our lead engineer. Before we jump into reviewing the past year of ACROX achievements, I'll be giving you all a quick introduction into what it is that we actually do. So the goal of the ACROX project is to create a family of successful CubeSats. For those of you who are unfamiliar, a CubeSat is a very small satellite that is usually deployed into low Earth orbit. ACROX is the reason that MSP exists today, And since our humble beginnings in 2014, our first CubeSat named ACRUX-1 was built from the ground up and sent into space in 2019, and we successfully established two-way communications with it. This was a huge success, defying all odds, and this is furthermore an amazing achievement for an Australian team, as we were the first student team to launch a CubeSat in 45 years since the Australis Oscar 5. Since ACRUX-1, we've been working on a new CubeSat that we surprisingly call ACRUX-2. Our mission statement is to be the first Australian team to develop a satellite to take a photo of Earth from low Earth orbit. ACRUX-2 is going to be 3 times larger than ACRUX-1, standing at 100 by 100 by 340.5 millimeters in size, and we're developing a lot of our own technology alongside some off-the-shelf components that we'll be integrating ourselves. Our most exciting addition is the remotely controlled camera, and UHF communications will also be directed through our in-house ground station that we'll be building and placing on a roof right here at the University of Melbourne. Regardless of how amazing this is, we don't just want to build this satellite, take a single photo and call it a day there. We also aim to facilitate an impactful commercial and/or academic use of the photos that we take during mission operations, making this useful beyond just MSP. Our intended capabilities for this CubeSat include, firstly, photographing specific locations within certain time periods, secondly, securely downlinking images using S-band, and thirdly, reliably operating our own ground station, including uplinking commands and receiving data. I'll leave the details for our engineers to delve into, but for now, I'll pass to Keshav.
Thanks, Tori. So earlier this year, we were actually presented with quite an exciting opportunity. While talking to a Berlin-based satellite team, PTS, we came to learn that they're in quite a unique predicament. They've been given a bunch of free 6U CubeSat launches by the European Space Agency, but because they were so close together, they didn't have enough time to focus on anything beyond the core modules of the satellite. This meant that despite having 4U volume, 6 kilograms of mass, and 4 watts of surplus power available for payloads, they didn't actually have any payloads. And so that's sort of where the ACRUX team stepped in. So our goal was to essentially incorporate as many payloads into their third launch, Curium-3. So we had to send our payloads to Berlin within a few months in time for their test campaign. So due to the time constraint and lead times on components, we couldn't actually use or develop any of our own payloads, and so we had to source them externally. We wanted our payloads to be beneficial to the broader space community, and so that's why we wanted them to have a research focus. And so what we did is we reached out to every Australian space research organisation we knew, and fortunately for us, Binar and Quava were able to provide us a list of viable payloads that we could use. Based on the integration constraints, we narrowed this list down to 3 payloads, so the charge exchange thruster, the electron density and debris instrument, and the radiation counter. So since the PTS team was preoccupied with an earlier launch, it became our responsibility to make this integration as seamless as possible. And so to do that, we were responsible for defining the intended operation of the satellite, and we acquired a development board with the same chip as their OBC, and we developed the payload control software for the OBC. We also developed a comprehensive mechanical integration plan, so we figured out where and how all the payloads were to be integrated. And alongside this, we also had to navigate the legal and logistical requirements with sending the payloads to Berlin. So that involved engaging with the Australian Space Agency to understand their permits process, setting up agreements between all the parties involved, dealing with defence export controls, and obviously we had to organise the physical transport of the payloads to Berlin. Now, somewhat tragically, around the time that we would have sent the payloads to Berlin, we found out that the PTS team had lost funding and could not proceed with the launch of Curium-3 as they didn't have enough money to get certified. As disheartening and as devastating as this was at the time, reflecting back, it was still a very valuable project for us. We managed to set up collaborations internationally and across Australia. We got a bunch of technical skills and experience across various new technologies, and we learnt a lot of important things for ACROX 2, particularly an understanding of the legal and logistical processes involved that will also be required for ACROX 2. And importantly, the partnerships that we formed with Quava and Bina actually continue to this day. So they've offered us access to hardware, testing facilities, and even mentorship, which will obviously play a critical role in the success of ACROX 2. Now, shifting our focus back to ACROX 2, we can reflect on the significant progress that we've made over the past year. So, one of our key strengths has been the network of partnerships that we've built. Beyond the collaborations that I've already described within Australia, we were actually able to get NASA to review our design documentation, and we've been engaging with a number of student teams globally. This is also a very exciting time for ACROX 2, as we're transitioning from the research phase into the development phase. This shift allows us to get more hands-on with the project and accelerate not only the satellite's progress, but our development as engineers. And now to kick off our sub-team presentations, I'd like to introduce Ayush from the camera team.
Hi, hello everyone. My name is Ayush, and I joined MSP around April this year, and just recently moved up to camera lead because the previous lead had to move to Sydney. But anyways, the goal of camera team is obviously get an image of Earth from low space orbit and as best quality as we can, and also communicate that to the onboard computer that we can constantly take photos and get commands. So currently it's very exciting times for us. We recently got all of our parts, so a lot of our parts came through. We have managed to set up the primary camera you can see on the left, and a backup camera has also arrived. So we took the primary camera out to do some testing, and so we got images of Kesh and Tori posing, but obviously not the best quality. So a bit of a failure, but I thought it was funny to include. So why it wasn't the best quality is because they were too close to the camera. I think it was around 400 meters, but obviously being a space camera, it's focused to infinity. So we took it out again and tried to get a photo like 2 kilometers out. And on the left, you can see the reference photo, just taken from an iPhone. And on the right is from the primary camera. And you can see the Scape logo pretty clearly. So that's better. And pretty excited to see, do more testing and see how far we can stretch the primary camera out. Other accomplishments we've had is to do the actual communication with the onboard computer. We have managed I2C communication as our backup, and we will be working on the RS-485 communication as our primary method because it has better electrical interference shielding. That's all the updates I have from camera. I'll pass on to OBC. Holly.
Good evening, everyone. I'm Holly, and I have the privilege of co-leading the onboard computer team. I'm honoured to present the progress our team has made this year. So the OBC is critically important for the functionality of the satellite, as it acts as the primary interface between the subsystems. Some of our team's objectives include coordinating commands between subsystems, monitoring subsystem health and managing data storage, such as telemetry and images from the camera subsystem. Our first major highlight was the recent arrival of the onboard computer from EnduroSat. I'm pleased to report that our team successfully uploaded the SDK, debugged and tested, and confirmed that the board is functioning as expected. Additionally, we've made substantial progress in the design and planning of subsystem interfaces. An example of this planning is shown for the camera subsystem, where we had an initial meeting to plan the functionality required. The next phase was then the requirements analysis. We are now undertaking the design process for the subsystems, where another example for the design of the camera interface is shown. As we move forward, we will soon be beginning implementing these interfaces using the SDK. So James and Tim Stang are now going to talk about the ADCS.
All right, hi everyone. I'm Timmy Sang, and I'm here with James to present about ADCS. So ADCS is a bit of a mouthful. It stands for Attitude Determination and Control System. Essentially, in a sentence, the problem statement is, given some direction we want to point to, how do we reorient the satellite to point to that direction? So on the screen there you see a block diagram. I'm a big fan of block diagrams because I think it's a good way to understand what's happening overall. So we essentially have two major blocks. We have the attitude control block and the attitude determination block. The first one is essentially the process of reorienting the satellite with a bunch of actuators, so a magnet talker and reaction wheels. Whereas the attitude determination block is about figuring out where we are and how we are pointing. Cool. So one of our lead engineers, Josh, did some simulations very recently. On the right of the screen there, what you'll see is the simulation essentially converging to zero in its angular velocity. So that's pretty much the stabilization of the satellite. And up top is the result of introducing a random step input. So as you can see, using a PED controller, proportional derivative, we have managed to stabilize our satellite to some specified orientation. This, however, did have some limitations in the sense that our control law doesn't explicitly account for gyroscopic effect just yet. That's something that we're going to look to introduce very soon, as well as the quaternion error approximation problem.
Cool. So over here on the right, we have our gimbal prototype. So we have two. The one on the left there is one we developed around 2 years ago. And initially, it was just used to try and test one reaction wheel. This was more of a proof of concept type thing, and we also wanted to try and test our magnet talkers. Now, we had a few issues with that system in general. It was very unbalanced, and it was very weight heavy on the bottom due to the battery. So we had to try and redesign. So on the right is our more advanced gimbal, and that's just on the table there. And essentially what we're trying to simulate is 3 axes. And this was when we were first trying to implement 3 action wheels, and then launch that system into space. Since then, we've actually tried to rescope our initial design, since the 3 action wheel implementation is actually quite intense for students in general. So we've since rescoped to 1 reaction wheel and then using 3 magnet talkers. Those magnet talkers would run constantly throughout the orbit to try and maintain our nadir vector, which just means maintain pointing down towards Earth. And then we also use this gimbal to try and simulate gimbal lock, which is a more technical type of error when you have 3 axes in space. And then, yeah, those are just 2 systems that you can have a look on the right there. Cool. So this is also our reaction wheel design. This was a very simple first prototype that we CNC'd. It's made of aluminium, and we have some of our interference data there as well. Now, we unfortunately don't have this with us at the moment, but we do have some more other cool, very cool, like prototypes on the table. We do have our reaction wheel driver, which Matt's been working on tirelessly, which is very, very cool. It's quite complex, and all we're trying to do is really drive the actual reaction wheel.
Cool. So at the beginning, I mentioned this thing called attitude determination, which also happens to be my research focus on the side. So now, what this is essentially a problem of figuring out where you are in space, so localizing yourself. So yeah, given some initial or some desired reference, we want to figure out where we are, and then once we solve that problem, we can then point to that specific direction. So then, now how do you solve this problem? A bunch of smart people a while ago came out and figured how to do this using just a bunch of math and block diagrams or what have you. It boiled down to two major algorithms. So the first one is the triaxial attitude determination, and the second one is the common filter. So yeah, it's very, very long, fancy names for estimation problems. So the way we're doing this, or the way we're implementing this, is using a suite of sensors. So we have sun sensors, 3-axis magnetometers, gyroscopes, and a GNSS receiver. So all this is just giving you an inclination of where you are in space.
Now, unfortunately, I'm not sure if this video is actually going to play, but if it did play, it would... Okay, cool. It would show, there we go, the actual stabilization of our attitude determination. Now, this is essentially how the satellite will actually act in space, when we need it to maintain its nadir vector or our Earth vector, or turn the reaction wheel some angle. This would try and stabilize itself. And that's pretty much it. Then if we go to comms, Kesh.
Right. So the comms team is responsible for sending commands to the satellite and receiving data down from it. This means that our system is split into the satellite and the ground segments. To achieve our intended capabilities, we're looking to implement two channels of communication. The lower frequency UHF channel is going to be used to uplink commands and downlink telemetry data. The satellite's UHF antenna is omnidirectional, so orientation of the satellite is not required for this communication. Meanwhile, the higher frequency S-band channel does require pointing, but offers a much higher throughput of data. This will be used to downlink images and greatly increases the number of pictures we can take and receive. Our active areas of development are also split up into the ground and satellite segments. For the satellite, we have actually pivoted to using the open source SatNox comms board. In addition to being a significant cost saving, the board has very advanced functionality and is able to operate across various frequencies. This allows us to continue our development without having a frequency allocation for the satellite. We've made minor modifications to the board and have actually sent it in for manufacturing. On the ground, we are developing our own UHF ground station. We have a location and an advanced amateur radio license to operate under. And we are currently developing the antenna tracking and signal processing for the ground station. When I met with the EPFL spacecraft team, I was fortunate enough to visit their ground station. And they've actually implemented a very similar architecture to our designs and have offered their guidance. So this will help us overcome some of the very many roadblocks. With that, I'll welcome Tharaka to give the EPS presentation.
Thank you, Kesh. I'm Tharaka from EPS. So we are electrical power systems. Okay. So I'll talk about two key elements we are currently working on. The first one is the harvesting board. So harvesting board is used to efficiently store the energy harvested by the solar panels. So after successful completion of version 1 of this one, we are currently working on the version 2. So here we are using a new chip which uses a more robust MPPT algorithm called maximum power point tracking. Also, this chip features few telemetry capabilities, so we don't need to implement different telemetry circuitry outside the chip, so it is integrated. So the point of failures go down as a result. So this is designed to use harvest energy from three U-sized solar panel arrays. So it is capable. One array is capable of harvesting up to 8 watts of power. Moving on to the second one. So we are working on the microcontroller unit for the EPS as well. So this will serve as the brain for the EPS. So it will aggregate signal from data from different sensors inside the EPS. So it will do some pre-processing and report back that data to the OBC. Also, it will serve as a switch and circuitry which is driven by the OBC commands. So we can cut and turn on the power to different subsystems. Also, it will monitor the health of the OBC as well. So in case of some internal loop inside the OBC, we can restart the system. That's about it. I will hand over to mechanical engineering team. Thank you.
All right, hi again. So I'm Timmy Sang again, and I'm presenting on the mechanical engineering side. So basically, our whole purpose as a team is to withstand the launch force as well as to do temperature regulation. There should be a third section there that says design the ground station, but for the actual flight vehicle, those are our two main contributions. So I'll just pass it to Guillaume to talk about his manufacturing process.
Right, so the two main considerations we had when designing the chassis was we needed it to be as cheap as possible, be able to withstand the forces, and be as light as possible. So we had a mass budget as well as a cost budget. What you can see to the right is the COTS version, the commercial off-the-shelf version. And to the left, you've got our first prototype we attempted. The first prototype you can see there, that was made with laser-cut aluminium, 3mm thick aluminium sheets, and then bent. We created the prototype and we found that while it did perform, it was within the weight tolerances we'd expected. It unfortunately didn't have the geometric tolerances we needed. There was just little errors that had occurred during the manufacturing process, bends that weren't quite at the degree we needed them to be, which was a little bit annoying. And so then our choices became, we could either send it off to be CNC bent, or we could get it CNC milled. And we decided to go with CNC milling. Next slide, please. All right, back to Kiev.
Cool. So speaking more on our second design purpose, temperature regulation. So we're going with passive thermal control, which essentially means we don't really use active power in our thermal control. So this consists of multiple things like multi-layer insulation, space-grade paints, thermal straps, and the like. Essentially things that don't draw power. So yeah, all of our simulations are being developed using Thermal Desktop. So thank you very much to Ansys who provided us with the software. Cool. And this is just a slide showing the importance of temperature regulation. So if it gets too hot, you essentially cook your spacecraft. If it gets too cold, the spacecraft will try to warm itself by drawing in too much power from the batteries, which is what killed ACRUX 1. Cool. I'll now pass it to Douglas.
Hi guys, good evening. My name is Douglas. I work for LEAP for around 2 years. I am one of the solutions engineer manager, so we are responsible for some accounts. Melbourne University is one of my accounts, and we are more than happy to sponsor MSP. Congratulations to all the team. My presentation today is talking about try to motivate engineers to learn properly simulation, and why nowadays the best time to start with that. Just very quick about LEAP. So we are since 1996, more than 50 and 60 engineers nowadays. Actually, most of them are engineers. We are one of the channel partners in ANSYS, Australia and New Zealand. We are not only seller provider, software sellers, but we also provide training, mentoring, and tech support. Here the team has the access for training and mentoring as well, and tech support, not only the software, so part of our sponsorship. ANSYS is number one in simulation, mainly because 100% of the R&D spend is focused on engineering simulation. And you can see the most different physics that we can simulate using ANSYS, not only fluids or structures, but electromagnetics, thermal, embedded software, also in different sectors in industry, like automotive, healthcare, high tech, and so on. Also, in most of the global leaders, and also some startups like Akulatech. Soon. Just start with the product development life cycle. So in the past, most of the company used to follow this process. So they start with the plan, go to design, yes, go to the physical prototype, evaluate. If it's not working, they get back to design, modify, go to the physical prototype again, evaluate. If it's okay, they go to production. The problem is sometimes you need to develop things that it's impossible to follow this process, like you see front protection for tram or train. So you can analyze different types of materials, not too soft, not too hard, different speed. So you can't develop this physically and then test. You need to do this digitally first. You have this two ships here. You cannot construct the ships and see how safe they are. Or even the thermal desktop example here. So you cannot send your satellite to the space and then analyze how it's going to happen thermically. So for that, we have CAE in the middle between design and prototype. So you have the digital prototype before. You're going to the physical, so you design, do your test digitally. If fails or if you're not happy with your design, you go back to your design, your CAD, modify, go to simulation, and do this cycle until you are happy, and then move to your physical prototype, so you can save lots of money and time. But of course, when we talk to companies about the introduction of simulations, they always going to put in a balance. They are going to analyze the return on investment. So, okay, what's the investment in hardware or software, and how long simulation is going to take, or it's hard to learn. Do I have a lot of training materials available? And just about costs of hardware. So nowadays become easier and easier for companies to move into simulation because hardware has become more and more cheap through the years. So even companies can buy a laptop and do lots of simulation. That's things that in the past wouldn't be possible. Another thing is about GPU. So GPU is not quite new in simulation, but has become more and more efficient. So nowadays you can even have multi-GPUs for simulation. So instead of 175 cores, you can have 8 or even 32 GPUs and speed up your simulation 68 times. You can see here how NVIDIA has been growing in your market, mainly because of the GPUs, not only because of simulation, but artificial intelligence itself. Here are some examples. Some side mirror with 3 million cells with CPU 32 cores. You spend 100 hours to simulate. If you have one GPU, you can spend just 7 hours, so 14 times more. Another example was combustion. In the past, GPU was not able to simulate combustion. Nowadays, you can. So you see that very similar. It's quite accurate, simulate using GPU. And one GPU is 12 times faster than 32 CPUs. Also, artificial intelligence, so it's everywhere, and also in simulations. I want to talk specifically this new product, SimAI, because you can speed up your simulations between 10 and 1,000 times. So how it works, actually, you upload your simulations. You train your model. It can take, depends on the complexity and how many simulations you have. It can take 1 or 2 days. But once it's ready, you just put your new design, and you can predict in seconds. And second means less than 1 minute. I'm going to show here some examples. Like you see here, it's 50 accurate simulations. So instead of 5 hours with 200 cores, which is very expensive hardware, with SimAI, you can spend just 30 seconds. Another example here, heat exchanger. So more than 250 simulations results. Instead of 2 hours waiting for the simulation, you can wait for 20 seconds. Another example here, who design, so more than 200 as well, simulations, and then instead of 4 hours, in 32 cores, you can spend 50 seconds to get the results. The last one here is the stirred tank, so instead of 12 hours, 30 seconds. So things that nowadays companies are, like, it's quite expensive product yet, but the same as 3D printing. It used to be expensive as well, but it's become cheaper and cheaper, yeah. Another thing that nowadays we have access is like learning materials. So nowadays you can go to the website, and we have Leap Learning Hub that you can access our training for free, structural fluids and electronics. ANSYS also has a learning platform for free for students. Students have access to student versions, student software specific for students, or you have access in your university. You can access YouTube channels. Leap has one as well. So it's quite easy to get access to training and knowledge, things that in the past you didn't have much. Quick as well about student teams. Nowadays, we have more and more student teams around Australia and New Zealand, like Melbourne Space Program, but rover teams or rocket teams, so we sponsor most of them. So they have access to ANSYS, and they can be more prepared for the market when they are, I think, when they are part of these teams. Another thing is about the market. So here's show, I just did a test, FEA, so almost 500 jobs. So companies are looking for engineers with this experience. ANSYS, FEA, almost 500 jobs, and ANSYS, almost 400. Leap, we are always promoting as well opportunities. So current positions here, like FEA, for Let's Dyna and Let's Dyna, or even STK. We are also looking for engineers with these skills. But yeah, just showing that nowadays company are more interested in using a simulation because it's become cheaper and faster as used to be in the past. Thanks so much.
Thank you, Douglas. So good evening, everyone. I'm Alina, the current project lead of the Humanoid project. And today I'm excited to share our work on this key date within the Melbourne Space Program. Great. So the Humanoid project focused on building a service robot that's capable of acting as a bartender and able to serve you drinks while engaging in the pleasant conversations. So our aim is to enhance human-robot interactions and moving beyond a simple machine to create a more interactive experience. Our team is composed of students from diverse academic backgrounds, ranging from undergraduates to masters and even PhD students. So this diversity drives our objectives, which include encouraging cross-disciplinary collaboration, refining teamwork, and improving communication skills. And if you joined us last year, you might still remember our ambitious goal that we want to design a robotic arm that within 5 degrees of freedom and capable of supporting an end weight of 0.5 kilograms. And we also focus on enhancing the software for a better interactive experience, allowing you to have a more engaging conversation with the robot. And so now I'd like to invite our members from our different sub-teams to provide more details, updates on our progress.
Thanks, Alina. Good evening, everyone. I'm Peter, and I am the sub-team lead for robotic structure at the Humanoid team. And at robotic structure, we're mainly dealing with a lot of the physical aspects of the humanoid. So anything from designing the actual arm to manufacturing mounting brackets for electronics, that's all on us. And so the main thing for this year is the addition of anthropomorphic end effector for our arm. So you can see on the left, that was our previous stage arm with a basic cup holder as the end effector. And while that worked, because we were a humanoid team, we do want to see a humanoid hand on it. And so in this year, we focused on trying to make a more aesthetically pleasing hands. And here we actually 3D printed this using TPU to mimic the natural motion, gripping motion of a human hand. And here we're actuating 5 fingers with only one motor. So this is an under-actuated system, and we could do this because the gripping motion that we need is just a basic gripping motion for now, like a bottle gripping motion for now. And so we can get away with having one actuator. And we're using links and cables to actuate the fingers. So here is a short demo. Not sure if it'll play. So that's a payload of 0.5 kilograms, which was our goal for this year. And you can see that we're able to tilt it and the motor doesn't lose power. We're able to manipulate the bottle. We did find that the skin of the surface of the hand was a bit slippery than we thought. And so we did need like a stopper, in this case a roll of tape, to allow it to grip it. But we can see that the grip strength itself is sufficient to hold a 0.5 kilogram of payload. This is a more close-up view of the mechanism, if it plays. So we can see that there's a spindle or a spool that's winding the cables, and it's in turn actuating all the fingers. And because this is printed out of TPU, the stiffness for each joint is actually slightly different. And so we're able to have that natural grasping motion by altering the bending rates of each fingers. Yep, and another area that we upgraded was the arm. So we now have a stronger arm with a longer arm reach of 50 centimeters. We also added another motor, so we have a total of 5 degrees of freedom compared to 4 degrees of freedom from our previous stage. We also created an enclosed torso design so that we can house all the electronics and power supplies necessary for it all in one place. It's not in the slides, but we do have panels that go around the torso so that it actually protects it. And I think we just saw a little bit of demo of the hand moving. So the future direction for our team is, first, we want to upgrade to a more modular torso design. We figured out that when we noticed that the current design we have had a lot of limitations in terms of modularity. When we wanted to place the components in different locations, we had a lot of trouble because basically we'd have to cut a new plate and then drill new holes. And so we want to stick to something that's more modular, so when we make mistakes, we can fix them. And so we're looking into aluminum extrusion to replace the current torso design. And we also are looking into new joint designs for the arm. We want to use DC motors and also cables, perhaps, to have a stronger, more smooth acting arm. And we also want to incorporate more CNC machine parts because we noticed while 3D printing is great for rapid prototyping and ease of manufacturing, they have their limitation in terms of rigidity and strength. So we're really looking into more rigid components to have more stability in the design. And hopefully, with all these modifications, we'll be able to reach our 1 kilogram of payload capacity by next year. And we're also more looking into dexterous end effectors. As I mentioned before, the skin was a bit slippery, so we're looking into maybe like a silicone mold or anything that could increase the surface friction. And now I'll pass on the mic to Alina.
Thank you, Peter. And now in the sensing subteam, our goal is to use a camera paired with the Jetson platform to build computer vision capabilities so that robot can recognize different types of liquids and bottles. So this is our first update. It's about our on-site data collection. So in this, we develop a data set at our workplace, focusing on 3 different locations. So one is from the meeting room and the top of the cabin and the kitchen table. While training our own model on this data set provide high effective, but the process was time-consuming and complex. So we are now exploring more efficient methods. And then we are considered about the background subtraction methods. Compared to the neural network approach, background subtraction is significantly faster and eliminating the needs for data labeling. Though it sacrifices some accuracy, but the figure on the left demonstrates how the background subtraction works. And it turns out to be very successful with colored liquid, but it's not with the transparent one. And if you play the video, you can see the demo video that when our members was moving the green bottle on the side, the screen was showing the data of the position. And this is also why we use a foot dice to turn the water green. But I believe most of us would prefer our water to stay clear rather than glowing green in our cups. So we explore additional technologies to improve the sensing process. We employed K-means clustering for color recognition, optical character recognition for text detection, enabling real-time identification. So then when recognizing a bottle, the camera will be able to report the position, color, and text label simultaneously. And for our goal for the sensing is to actually develop a neural network that offers a better performance. And we also plan to create a gathering node that we're able to act as the robot's brain and send comments to each part of the system. And now I will pass to Antonio about the chatbot.
Hello everyone, I'm Antonio, Humanoid chatbot team lead, and the chatbot team is on about communication with the client. We have to receive the order and understanding and give feedback. So I'm going to walk you through our progress for this year that we have done for now. Firstly, we have set up the Raspberry Pi, which is the hardware. Every software application is inside of it, and we were able to have a basic conversation with it. Our robot is called Ida, and she knows he's a bartender, so we can have a communication, order drinks with her. And we also developed a noise reduction application, so it's improves significantly the understanding for Ida. And the last update from us is we are creating a custom voice model. It's still in progress. We haven't finished yet, but we are still doing it. So we want to let Ida have his own voice instead of just robotic. So this is a demo video. So in the left side is on the component, and on the right side is the demo. Well, right now it doesn't show any sound, but I invite you guys to come later for our right here, and you guys can have a communication with Ida. Oh. So that is Ida.
Hi, Ida. I would like to order a green drink.
Sure. I'll get you a bottle of green drink with mint flavor.
Yeah, that's basically it. And the communication can still go on. And for the future direction, we can divide the task into two parts. From one side, we want to have the chatbot enhancement. We want to improve the chatbot deeply. So from one side, we want to train the personality for Ida and let Ida to start memorize the conversation. And also, we want to have the cross-project collaboration. So we want to integrate the chatbot with another sub-team, like the robotic, the sensing, so everything comes together. And I'm going to pass Anina for close.
Hi, it's me again. So our next step for Humanoid project will still be focused on enhancing both hardware and software. And on the hardware side, we plan to design a new arm capable of supporting up to 1 kilogram. And we can try to create a vivid facial expression, so it can also do a response based on what you talk to her. And we also plan to develop a smoother trajectory for holding the cups and pour the drinks. And on the software side, we aim to improve our chatbot's ability to store and record customer interactions and implement neural network for more accurate bottle recognition and build nodes that enhance communication across different components of the robot. And I believe these advancements will not only bring us closer to achieving a more sophisticated and interactive service robot, but will also provide us with invaluable experience in robotics and AI. And we are excited about what the future holds and look forward to share our continued progress with you. Thank you.
Yes, I would like to now invite Sean to come up and speak to us. Thanks so much for your time.
Hi guys, I'm Sean from Altium. Been working there about 5 years now, and I'm the Senior Account Manager. And we work with majority of the universities and sponsor most of the teams. Hopefully some of these slides work, just bear with me. So we actually started off out of the University of Tasmania in 1985 as a startup, and we've sort of grown to be one of the world's highly used PCB design tools globally. Have around 1,000 employees globally, and we are kind of listed on the ASX and one of the highest performers, but things have changed as of 1st of September. Obviously, we're Still Australian-based, well, kind of, with a global footprint, with offices everywhere. It's just some revenue and projections and users that we have globally, and the types of companies that we work for. So pretty much, if you think electronics, we work for everybody. We get pretty good ratings from people too. I guess education is a very important platform as well. So with the sponsorships that we offer, obviously we give free training to the teams on our essentials training or more advanced courses. But also we offer free training via our site. So all you need to access, the basics of PCB fundamentals is your student ID or email, and you guys can pick it up. But yeah, this is the interesting news. As of 1st of September, we've been bought out by a company called Renaissance, which is a global leader in semiconductors and components, and was a record for software company sale in Australia. So roughly $10 billion they bought us for, which is very surprising, but yeah, interesting times at the moment. We've got a lot of good case studies about how companies use us. They're called LTM stories. I did have a website, but I can't find that at the moment. Actually, there's a board down there. So check that out. And also, we're currently doing one with Melbourne Space Program. We've probably been working on that for about a year now. And, in the following year, we're going to see the launch and a successful launch too. I might jump a couple of slides here. So just talking about some of the companies and startups that we work for. Applied EV is quite interesting. So this is called the blank robot. So essentially you can put anything on top of the blank robot. So it can be used for, a cafe on wheels or delivering medical supplies, whatever you can think of. And it's all mobile controlled. So it's just like your Uber. You punch in, I'm starting here, going to there, and it'll just take you where you need to go. So it's got three main things. Digital backbone is probably their most important product, which is the backbone to create a car that is totally autonomous. And you can put the digital backbone into any car that you want. So it could be a truck, it could be your favorite classic car, etc. The blank robot is a couple of years away, I guess, but that is the cool thing that you just saw. And then the mobility solutions. So that's the digital backbone and how it works. And mobile and blank robot. So we've got a lot of clients. This is New Hero, which is a non-intrusive hearing aid, but back in 2022, got into Time magazine. I don't know, who knows Time magazine? Everyone? Yeah, cool. I thought I was a bit old, and you guys might not know. But yeah, it's very impressive that they got into the top innovations of that particular year. Another company we work closely with is Gilmore Space. They kicked things off in 2015. They've grown quite significantly. They're building smaller rockets with smaller payloads, which are cheaper to put up. Yep, that's very cool. Doing good things. I think I've got a picture of the size of the rocket, which when you've seen things like SpaceX, etc., it's tiny in comparison. Other good startups that we work for are things like Fleet Space Technology. I thought I'd include that since you're a satellite, you're building a satellite. They're based out of South Australia. Very, very cool team. They build everything in-house, and they've got one of the largest 3D printer in the Southern Hemisphere, which is pretty impressive to see. Essentially, I think that's the size of it there. So a bit bigger than yours, but once it gets up to space, just unfolds the solar panels, etc., and runs forever. This is their sister company, which is Airspeed. Obviously, they've got some impressive sponsors like IWC and Altium, of course. But it's going to actually be a flying drone. You're going to put a person in it, and they're going to be racing. And it's sort of, in the future, they hope to sort of compete with F1, with viewership and all that kind of thing. And what I've seen so far, it's pretty impressive. You know, racing across mountainscapes, across deserts, all these cool things. Like, can't put a person in it. Well, they have been putting people in it, but yeah, it's just testing still at the moment. Obviously, we sponsor a lot of teams. SunSwift is just one that I've had a lot to do with over 5 years since I've been at Altium. They actually won the global challenge, which is called, essentially they go from Darwin all the way down to Adelaide, and it's a global competition, and they won the one last year. But I guess the next slide, they're actually going to create something different. Like, this car here is actually a four-seater. The minimum requirement is 2 seats. A lot of other universities only use 2 seats, but they kind of want to head towards being actual road car for development and all that. But the next one, and they're led by a pretty impressive guy as well. His name is Professor Richard Hopkins. He's not a real professor, I guess. He's an honorary professor, but the reason why he is a professor is for the last decade, he's been the Chief Operating Officer of Red Bull Racing F1. So it's a very, very impressive title, and you've probably seen like Red Bull in the last year coming from down there to being the leading team globally in the F1. But this is really, really impressive, this next slide. They're going to be one of the first teams to actually build a hydrogen car. And that's what they've started working on. And it looks cool. And they do have the right backing as well. Obviously, Audi's helping them design this, and it is a cool car. I've got my order in already, and it's ready to go. So hopefully a video starts now. Does anyone know how to hit play? Oh no, here we go. No. Does anyone know how to work this? Tell me. No, that's not going to work. No. So I thought this would go and give you a very good overview about what Altium does for startups. But I guess the reason why I like working for student teams is what I found many, many years ago was that you guys were all using individual student licenses. And what happens is that you guys finish each 3 to 6 years, which is common within any business. So what I've sort of thought about and started doing with all the universities across Australia is set you up as a business. That way you can use the A365 platform. Everyone can be involved in the same ecosystem. You can work and develop on your designs and all that kind of thing, but when you leave the university, then the next group of students can pick it up, but they can see all the past work, all the past revisions, and continuously improve on what you guys have been working on for years and years. The worst sort of problems that we did find, and I think you guys might have done this as well, I can't remember Max, but one student left, you couldn't get in contact with him. I think he had all the designs for one of your controllers. Is that you guys? Yeah, it is. And then you just know that that's wrong. So now you guys have one ecosystem where students can leave, new students can pick up, and just continuously improve on your design, and yeah, just hopefully become the world, you know, winning competitions and all that kind of thing, but have all the different people involved. So it doesn't matter if you're electronic design, they're in there. If it's mechanical design people, like obviously we integrate with SolidWorks and all the MCAD programs. We also integrate with ANSYS, as we discussed earlier, and we work closely with LEAP. I'm just waiting for summer, and I'll go visit your offices in Manly again. So yeah, that's why I really, really enjoy the student sponsorship program, because yeah, I get to treat you guys just like any other business, and you've got this complete ecosystem to work out of. You can share your designs with the manufacturers. They can have a look at the design. They can get back to you, go, hey, look, that's not going to work. Can you do this? But same sort of methodology applies with your MCAD teams. You know, there's always that sort of fighting, or you're packaging up emails, and that's not very efficient. Like, you just want a single source of truth that, yeah, it always is in there. You can always go back. What did that person do a year ago? Where did we go wrong? How can we fix this? And yeah, so that's Altium. Thanks, guys.
It's not working, is it? Oh, there we go. Hello, my name is Wara, and I'm the team lead for Animatronics. Yeah, this will be the last thing in the presentation. I'm excited to sharing progress over the past year. So, before we begin, what is Animatronics? So, our project centers around the problems at a children's hospital. There are limited play opportunities for children. Children can get anxious waiting, and clinicians do not have the resources or time to address this problem. The solution is to build an animatronic robot, or multiple of them, to make children's hospital visits a bit livelier. So, over this past year, we've had an animatronic dinosaur. This year, March, we had volunteered at the Teddy Bear Hospital, which is a fundraising event for Royal Children's Hospital. What we found was that a lot of children really did like the dinosaur, but it may have not been for everyone. Some smaller children did get a bit scared off. So when considering this issue, we decided we will make another animatronic and continue to make new ones every year. This year, we've chosen a quokka as a small furry animal to contrast with the dinosaur, help fill the niche. And for every animatronic we make, we want to have expressive animations and the aspect of tactile sensation, which we had positive feedback for in the last event. Additionally, we will use the experience learned from previous animatronic projects to help new members gain the skills in order to build new ones. So, our path to integration for this project, the quokka, we are currently at the first stage, which is individual works-like prototypes. We have mechanisms, a circuit, and software and web app prototype developed, tested independently, which we will then combine later to make sure that all the mechanisms and the software work within one integrated system. After that, we'll have individual prototypes scaled to fit within the final model. So our first prototypes are not to scale. We then scale them down. For the full quokka, we'll have development for basically the exterior, the skin, making sure that everything fits nicely into place. And then when that's all tested, we'll have a demo. We'll be right back at any events that the Royal Children's Hospital want us to be in. So just to go into a bit of detail into some of the progress that we have made so far, we have a quokka remote app, which is like the dinosaur, a web app on a mobile connected to the animatronic via Bluetooth, which will control basically what state it is in. What these states will do is that all the movements, expressions are automated, but you can influence the probability or the rate in which they occur. And that's what we have active, which is for most movement, passive, less, and photo for being still. We also have a prototyping mode to control individual servos to make testing the mechanisms a lot easier for mechanical engineers. Oh, Sorry. And finally, for mechanical design, we do have some individual prototypes in the works. We usually create them via CAD software and then 3D print them individually, test them. We have a video right here, which hopefully will play. But yeah, there we go. So we have those 3D printed, assembled, and tested. And then later down the line, when we've done all of the features, we'll integrate them. Yeah, that is for the future. So, yep, thank you very much. I'll pass it back to Marcel.
Well, thank you so much for that. And I would like to thank everyone who's been here. Thank you for your patience. I would like to thank Pritam, our first speaker, for sharing your journey through space, from university to Melbourne Space Program, and then starting your own company. I'm sure that's been very inspiring for everyone. And Dropout Chai, actually, I've been to Dropout Chai, and the chai is amazing, so definitely recommend. And also, thanks for sharing. What stood out to me when your message was the lessons in business, people management, and how legacy is at the heart of your business. That really stood out to me. And Douglas as well, thank you so much for sharing your message, and thanks so much for your time. I actually had the opportunity to meet yourself last year, so it's great to see you here again. And Sean, thanks so much for such an impressive presentation. Very cool technology that you've shared with us. And thanks so much to everyone else for being here. We have feedback surveys, so please share some feedback. We are new to event planning, and that's not really our like expertise, but we're doing our best. So thanks so much for your patience. We have drinks and canapes now, so please enjoy that. Please leave survey. Please come to speak to us, and please meet our student teams. I'm sure they're very excited to share their designs with you. Thank you so much, everyone.